The objective of this lab is to verify Newton's second law, sum of the forces equals mass times acceleration, and to measure acceleration due to gravity, g. The materials used in this lab are one cart, one pulley, one string, masses ranging from 0.2 kilograms to 1 kilograms, a stopwatch, meter stick, and a scale, its spring or another type. Setup. A cart of mass m cart with an added mass m on a table is connected by a string to a mass m hang, which is hanging over a pulley that is fixed to the edge of the table. The length of the string, x, is just long enough for the hanging mass to touch the floor when the cart touches the pulley. A diagram of the lab setup can be seen here. A free body diagram of the cart can be seen here. A free body diagram of the hanging mass can be seen here. A mathematical evaluation of Newton's second law regarding the free body diagram can be seen adjacent to the free body diagram pictured. An evaluation of Newton's second law equation regarding the hanging mass can be seen adjacent to the free body diagram. A derivation of acceleration can be seen here. Please enjoy this demonstration of the lab. Procedure. Procedure. In this experiment, you will measure the time for a cart to travel the distance x, as the mass added to the cart is changed. You will later calculate the acceleration from x and the average time for the cart with different added masses. 1. In preparation. Weigh the cart, then determine its mass. An experimental value could be 0.2 kilograms. Enter this in column 1. 2. Hang a mass 10 or 20 grams on the end of the string. Record this value of the hanging mass, m hang, which we found to be 0.02 kilograms, and enter this in column 2. And 3. Measure the distance that the cart travels, which x for this experiment is 0.6 meters. This should be the same as the distance from the floor to the top of the table. Enter this in column 9. An example of the data table can be seen here. In preparation, step 2. For each of the following 5 masses, m is equal to 0.2, 0.3, 0.5, 0.7, and 1 kilograms. Put the mass in the cart. Then, pull the cart back until the hanging mass just touches the pulley. And 3. Let go of the cart and time how long it takes for the cart to reach the pulley. Do this 3 times. Enter this in time T1, T2, and T3. Sample times can be seen in the data table above. Analysis questions. Analysis question 1. For each row in your data table, calculate the average time and record the results in column 8. An example of the results can be seen here. Question 2. Recall that x is equal to v0 plus 1/2 at squared. Manipulate this equation to get a formula for a in terms of x and t. Hint: what is v0, the speed the moment the cart is released? Well, x is equal to v0 t average plus 1/2 at average squared. At this point, v0 is equal to 0. Therefore, we get a is equal to 2x over t average squared. 3. Use the above formula to calculate a for each of the total masses in table using the appropriate average time. Record these answers in column 10. An example can be seen here. 4. What happens to the acceleration of the cart as more mass is added? As more mass is added, the acceleration of the cart decreases. This is due to the inverse relationship between mass and acceleration with respect to force, i.e. Newton's second law, sum of the forces equals mass times acceleration. Analysis question 5. Explain what inertia, mass, has to do with the acceleration of the cart. Inertia affects the acceleration of the cart by affecting the magnitude of force on the cart. Due to Newton's second law, sum of the forces equals ma, mass and acceleration are inversely proportional. Question 6. For each of the rows in the table, calculate F equals ma and record your results in column 11. An example of question 6 can be seen here. 7. Then calculate the average value of F equals ma and record your answer in the bottom right cell of the table. An example of question 7 can be seen here. Analysis question 8. Notice that F is approximately the same for all the rows. This force is also just the weight of the hanging mass. F is equal to m hang g. 1. Give your average F and find the value of g. And 2. How does this compare with the accepted value of 9.8 meters per second squared? After the algebraic derivation, the experimental value of g is 9.8 meters per second squared, which is approximately the accepted value of g. The application question should be answered as a class. Thank you for your participation in this online lab. See you next time.